Most people enjoy the textbook material more so than the stuff we do outside the textbook. That's the truth. However, the textbook questions are open-ended, so I will walk around to see if I can assist any group, like if you have a specific question. I'm not going to tell you the answers, but you know how, like, a guru or someone kind of crazy will just ask you another question and try to help you answer your own question? I try to do that kind of insanity thing. So today's the day we start discrete, the discreteness of discrete math. The first chapter only has 3 sections. It's an extremely short chapter. So I realize you just took an S, and you don't want me telling you that eventually there's going to be an excess. But eventually there is, because there's only 3 chapters, 3 sections in this first chapter. Good Lord. English is not my favorite subject today. Okay. Today. Let's see. Well, you know my favorite subject is math. Let's talk about factoring. The first thing I do when I see any problem, the very first thing I do when I see any problem, is think about, is there a GCF? Is there a number or a variable or something that I can pull out of all the terms? I see a GCF that I can pull out on number 1. Yes, dear?
9y.
You could pull out a 9y. And if you pulled out a 9y, what would you be left with?
3y plus 2.
Okay, so she said, hey, they both have a y in common, so I'm pulling out a y. They both have 9 in common. 27 divided by 9 is 3. 18 divided by 9 is 2. Are there any questions about number 1? No. Perfect. There is another GCF problem. Oh, look, we could probably GCF on number 2 even. Number 2, I see something that I can pull out of all 3 terms.
2.
I can pull out a 2, but is there anything else they all have in common? And table 2, you get a point, by the way. Yes, Nyla? Yes, they have a 2AB in common, so let's pull that out. So what would we have left? Why would it be? Oh, yeah, it is negative 2AB. I'm not even noticing that negative sign. Negative 2AB, and then minus 4B, and then what? Plus 1. Perfect. Mine's a little ugly, but yours is perfect. Add a point for that. And, yes, number 3. Go ahead.
On number 2, does it matter if you pulled out a negative 2?
No, if you pulled out a negative 2AB, that's fine, but then you're going to have all opposite signs. So 2AB plus 4B minus 1. It does not matter. Either's okay. Yeah, either way it's going to have the 1. Because you pulled out a 2, an A, and a B, and there's still technically a 1 left. And how to check yourself? How can you check yourself with factoring like this?
Foil.
You could foil if it was 2 terms. What am I going to do if I multiply it all back in? What is that called? I could distribute. Table 2, get the point. Okay, number 3, yes, dear.
Pull a 3 out of all of them.
Okay, what would you have left?
5w minus b.
W minus V, that is correct, and your group can have a point. Okay, now for number 4. Let's go to it. I would love to hear, table 2 still in all the points today. Anyone else got something they want to say? Well, let me just leave through on the screen for a second. Oh, yes, dear. Number 4.
You can pull out a unity.
You can pull out a unity. Why can you not pull out a 7?
Because of the UT by itself.
Because that last term doesn't even have a 7. So if it was just, so let's look at that one. If it was just this, I would say pull out 7 UT squared. But it's not. That last term's slowing us down. All we can pull out is UT. Because that last term is not a multiple of 7. And what would you get remaining, Craig?
7UT plus 21T minus 1.
21T minus 1. Perfect. And your group can have a point. And now for number 5. Yes, please volunteer for something.
Take 5 out.
And? Yes, and what would be left?
3 plus 5 is squared.
Woo! Adjust that.
I'm just saying.
Okay. So it's not going to be x squared, because then that would be if we were to multiply it back through, he would have had x cubed. But now if we wanted to check ourselves, we could. If we distribute, we get 15x plus 25x squared. Hey, I know I'm right. That's why I know this answer's right. I can check it with distribution. Okay, and see how we're dreading these, and most of us hadn't even started these, and they were so easy. And number 6, you're not going to like what I have to say about that. Yes, dear?
Just W.
We are so on the same page. You can add a point for that. On number 6, because of that decimal, now if it was 16w squared plus 6w, I would say, hey, let's pull out a 2w and get 8w plus 3. Like, I'm with you. But it wasn't 16. It was 1.6. And then your life starts getting complicated. So me and Mr. Moore have argued about this problem all day. Me and him are both lazy. We say just pull out a w, have 1.6w plus 6 left. But we acknowledge you might actually have to pull out like a 0.2 or something weird. Something weird. We can see it happening. I don't like to. This is all I would do. But hopefully what's going to happen is Matthew's smart enough. If he had this problem on the ACT, he looks at the answers. He doesn't even bother to factor himself. He just distributes. No, you got me foiling. He just distributes out all the answers to see which one matches his original. Okay, and your group can have a point for that. Are there any questions about math workshops? Okay, then go ahead and open your textbook to the very first page. We might not be the very first page. Go ahead and open your textbook to page
14 says document.
Page 2. It says at the bottom, it says activity cross the bridge. And I'm going to steal Allie's book for a second. She does not mind. Okay. You are not going to believe this, but this is all we have to do today. Now, some days we have to do more than one activity, but this activity, since our first one, is going to take us a couple of minutes. In order for your group to get all your points, everyone has to participate in the group activity. Okay, there are 4 questions that you'll have to answer. And before you go, one, we need to discuss what a tree diagram is, and then 2, let's read the scenario together to make sure we're on the same page. Okay, so I want to discuss how to draw a tree diagram. So you can, in life, and I'm being a complete girl, but this is how my thought goes in the morning. So I pick out my shoes. And then once I pick out my shoes, that, based on their color, I'm either going to wear my black pants or my brown pants. And then I have like a polka dot shirt I like. You don't have to draw all this. I'm just giving you an example. I have a polka dot shirt that I like with my black pants. I have a white shirt that I like. And then I do have a gray shirt. But any girl would tell you, I'm probably not going to wear gray with brown. That's not going to work. And that polka dot shirt does not look good with my brown pants either. That white shirt looks okay, though. And then I've got me a pink shirt. And you're like, Miss Compton, you're being ridiculous. You don't actually make out this chart. Well, no. But in my head, I go through these steps, just like you do every morning with something. There's something that you think this process through of, if I pick these shoes, and that leads me to these pants, I'm therefore going to wear this shirt today. Or, if I eat this for breakfast, I want to drink this. And you make this kind of a thought process in your mind all the time of like, if I do this, it will lead to this. And you consider all your different options. And this is called a tree diagram. Now, you do not have to be my twin. Your tree diagram might be, for a boy, it's not going to be that complicated. Yours might be straight up, your shoes led to your shoes went to your shirt, went to your pants. Like, is that straightforward? Your tree diagram might not be as complicated as my tree diagram. But regardless, what we're doing in this first chapter to get introduced into how we think in Discrete is dealing with logical arguments. So you have to just consider all the options. And a tree diagram is a nice way to list all the options. So the only reason I like tree diagrams is they help me list all options. But heck, you realize sometimes some options die. Like, I'm not going to lie to you. The other day, I stained my brown pants. So that's not even an option for me anymore. Like, my only options if I'm wearing pants at the moment are black pants, which limits my shirt choices. I realize this. And that's the same kind of thing you're going to see today, is that sometimes there are limits, because I think this is about people being fat. So, no, about the speed of people. Okay, are there any questions about a tree diagram? Then let's read the scenario that you're going to have to figure out And obviously I'm recommending you use a tree diagram to figure it out, but you have your own brain, you can do your own thing. Notice that we pick people with A, B, C, D names. That is intentional. So rather than Hunter listing the name Doug every single time, he can just use D for Doug. So he can use A for Alfred, B for Bruce, C for Kathy, D for Doug. That's it. Okay, so Alfred, Bruce, and Kathy were coming back to their village in the middle of the night. This tiny bridge to the town is too small for more than 2 people to cross it at the same time. So obviously there's a bridge, and it's too small for more than 2 people to cross it at the same time. And of course, since it's nighttime, it's only safe to cross if someone is holding a flashlight. So since they only brought 1 flashlight, darn it, someone has to return with the flashlight every time. So for instance, if me and Matthew go across the bridge, either me or Matthew is going to have to bring back a flashlight because we have the only flashlight. Otherwise, we're leaving everybody else in the dark, and you see how that would be scary. So someone has to return before 2 more people can cross. So far that sounds easy. You're like, okay, I just said, for instance, with Matthew's group, if me and Matthew go and I return, and then maybe I take Brandon, and then I return, and then I take Eric, and then I return, and then I take Madeline, and then I return. And you're like, yeah, you just keep being the person that goes back and forth. That's easy, Miss Compton. But, you know, I'm not as fast as Madeline is. And then Matthew might be faster than her. So that's what the end of this says. Doug, bless his heart, takes him 10 minutes to cross that bridge. Kathy only takes 5 minutes. Bruce is fast. He can go in 2 minutes. Alfred is only 1 minute. But unfortunately, when you walk across the bridge with someone else, you can only cross at the speed of the slower person. Because obviously, but let's think that through. That makes natural sense. So if me and Matthew are walking across and he's the 1 minute and I'm the 10 minute, he's not going to leave me and run off with that flashlight. He's going to walk at my slow grandma pace until he gets me across, and then he'll lickety-split go back and get someone else.
Can't they just like walk in a combo line?
They can't, only 2 people can go across the bridge at a time. Because that's how wide the bridge is, or they will die.
They walk out a line.
They will die. Only 2 people's weight can go across the bridge at one time.
Sacrifices must be made.
Okay, so I know you have some great ideas, and this is your chance to talk about them with your group. There are 4 questions you must answer. I'm going to bring you around a piece of chart paper. When you've reached your final answer of how you're going to do this, we're going to put it on the chart paper. If you finish early and feel like doing something else, my logic puzzle's up here, but it's not mandatory today. We'll get to it tomorrow. It's fine.
So if there are 2 people